Good evening. Welcome to this, the second in the series of Provost talks featuring innovative and impactful research that's happening across VCU. The series is co-organized by the Office of the Provost Soteropoulos, and the Institute for Contemporary Art at VCU, which is where we are tonight. I'm Dominic Wills, and I'm the Executive Director of the Institute for Contemporary Art at VCU. So for this second in the series, we're very pleased to be able to welcome and hear from Dr. Frank Gupton. As many of you know, Frank Gupton is the Floyd Gottwald Chair of Pharmaceutical Engineering and the Chair of the Department of Chemical and Life Sciences Engineering here at VCU, and also leads the Medicines for All Institute, which is dedicated to developing new drugs and advancing access to new drugs around the world. And Dr. Gupton is going to talk to us tonight about the work of Medicines for All Institute in relation to the COVID-19 conditions that we continue to live under. Dr. Gupton is going to present for about 15, 20 minutes. We've had some questions submitted in advance, and so I'm going to, as I did last time, use those questions to guide a conversation in relation to the presentation and other issues. And then we're going to open it up to the audience that we have here in the auditorium of the ICA tonight. Before I hand over to Dr. Gupton for the presentation, Provost Soteropoulos couldn't be here this evening. He's in transit from the VCU campus in Qatar. And so he actually recorded a message of introduction for us. So we're gonna play Provost Soteropoulos' video introduction, and then I'll ask you to welcome Dr. Frank Gupton. Thanks very much.
Good evening and greetings from Doha and the campus of VCU Qatar. Although I can't be with you this evening, I want to welcome each of you to the second installment of the Provost Lecture Series at the ICA. Tonight, you'll have the pleasure of hearing from one of VCU's great researchers and societal problem solvers, Dr. Frank Gupton, Professor and Chair of our Department of Chemical and Life Science Engineering in the College of Engineering. I won't steal Dr. Gupton's thunder, but in his talk, you will learn that his work is fueled by the collaboration of faculty from a variety of disciplines who combine their unique talents to accomplish great things. In other words, it's transdisciplinary. And transdisciplinary research seeks to solve major societal problems that are important to all human beings. And every academic discipline, from the arts, humanities, social sciences, medicine, and the STEM fields, has a contribution to make in finding and implementing such solutions. In fact, here at VCUQ, which has primarily arts and design curriculum, faculty and students are working with colleagues at our Richmond campuses and from the universities represented in Doha's Education City to address challenges facing Qatar's rapid cultural, economic, environmental, and urban transformation. There are just so many ways that VCU faculty are making a difference in the world. I know that this lecture series will inspire discussions, new ideas, and perhaps budding researchers of the future. Thank you again for joining us tonight. Dominic and Frank, I will be enjoying your presentation via live stream.
Please welcome Dr. Frank Gupton.
So Dominic and Fotis, thank you very much for the opportunity to come and talk to you tonight about the work that we're doing here at VCU. I think that one of the things that has kind of shocked me in talking with people before this talk, how many people didn't know about Medicines for All? And so one of the things I'm going to try and do tonight is shed some light on what it is we're doing and why it's so important. It's not only VCU, but the state of Virginia, the nation, and actually internationally. So let's see. How do we get started here? There we go. So the topic of my talk tonight is about access to global healthcare in a post-pandemic world. So every one of us in this room and on streaming has been touched by COVID in ways that we hadn't ever contemplated until the disease hit. So when you start thinking about it, it's affected our economy, Everybody sees today the effect of inflation that's indirectly an effect of that, as well as all the other aspects of our national economy as well as our global economy. Second thing is hospitality. How many people in the room here have gone to a restaurant that's now closed? I mean, and found that it was closed. So these are the things that we take for granted, we've taken for granted before COVID, in addition to this issue about education. Now, I think Virginia has been kind of the epicenter of this issue about, do you wear a mask or do you not wear a mask? Well, fortunately, I'm far enough away from you where I don't have to wear a mask right now. But I think that this is one of those issues that's had an effect on the education process. One of the things I found out from my daughter-in-law was my granddaughter, Annie. They said that she was having trouble communicating because one of the cues that students get in the classroom is the reading lips. And you can't get that when you're wearing a mask. So that was one of the things that was a takeaway personally for me. Then the other thing about physical health, I think that one of the things I think about is being part of the senior citizens group. I'm what's referred to as immunocompromised. So all of us have to think about that, those that are 65 or older. The other thing I think about that's really affected me and others is I used to travel a lot to go around to speaking engagements. The last trip I took was to a meeting at the Gates Foundation, and it was in September, it was in January of 2020. And while I was there that weekend, case 1 in the United States for COVID was identified. And so that was kind of an interesting thing for me, but I haven't been on a trip since then. So I think about that from my perspective, but I know it's affected everybody. So the other thing is entertainment. Now, I thought this was an airplane picture, but my assistant informed me that that was a movie theater. So people in the movie theaters are actually having to deal with this the same way. And God knows I'm probably not the best investor in the world, but I never invest in a movie theater in these days and times. The other thing is mental health. How has that really directly or indirectly affected all of us in how we interact with one another? And the lack of interaction that we've had between us and the ones we love, as well as the people that we don't see anymore because they're all staying at home. But lastly, I want to talk about healthcare and the supply chain. That's going to be the focus of my talk today. And one of the reasons why I think this is really important is that we're trying to solve some fundamental problems that existed long before COVID, but COVID actually gave us the opportunity to get insights into our inherent vulnerability in the way we've been managing our global healthcare supply chain. So with that, I'm going to move over to questions that I'd like to get answered today. So the first one is, what is Medicines for All? The second one is, how is it related to COVID-19? And the third one, and probably the most important one, is why VCU? So with that, I'd like to talk a little bit about how this all started. So the Medicines for All Institute, the focus of the work that we're doing, as Dominic said earlier, is improving access to healthcare. I mean, that sounds like a pretty simple thing. And one of the things I try to teach our students is when you're talking to somebody, don't overwhelm them with a lot of extra information, because it's supposed to be a conversation when you talk to somebody. So when I tell somebody asks what is Medicines for All, this is very simply put what we do. This is our elevator speech. But the focus is on active ingredients, and the acronym that we use for that is APIs. It's active pharmaceutical ingredients. And so what APIs are is the biologically active material that they put into the tablets. It's typically a powder, but it's the most expensive component, clearly, in the drug manufacturing process. So secondly, what we do when we're working on that is to try and figure out how to produce these molecules in as efficient manner as possible. And my students tell me it's mainly because I'm cheap. And I think that there's a lot of truth to that because it drives a lot of the decision-making that we make in deciding the best way to put these molecules together. And then secondly, we work on automated manufacturing platforms. One of the interesting things about the pharmaceutical industry is they're not using 21st century technology, they're not using 20th century technology, they're using 19th century technology. They basically haven't changed the manufacturing platform since the turn of the century in the 20th century. And it's basically being driven by chemists. And so basically what you have is reactors with big round bottom flasks that make these drugs. And what we're looking at doing, one of the interesting aspects of that is if you look at the gross domestic product, the GDP, the pharmaceutical industry represents roughly about 10% of that, of the GDP. It's the only major manufacturing operation that doesn't use a conveyor system to produce their product, to be able to produce it efficiently. So, the other thing that we look at is starting with commodity-based starting materials. The reason why we start with that is because they're less expensive. But the other thing it does is it strengthens the supply chain because these are the things that are readily available to everyone. And then lastly, and probably equally important, is that we start with a really low carbon footprint. And what that means is there's very little pollution with the processes that we develop. Pharma processes historically generate several hundred kilograms of waste per kilogram of the active ingredient. And I'll talk a little bit about what we've done with some of ours. And it's been one of the main reasons why these processes have gotten taken up into the marketplace and by manufacturers as quickly as possible. So why is this important? And why VCU? It's because I am kind of a square peg in a round hole, and I'll talk about that a little bit later. But I'm an organic chemist, and I'm chairman of the chemical engineering department. And I'm comfortable with that because my research groups, when I was in industry, were a 50-50 mix of chemists and chemical engineers. And so my lab reflects that now, where chemists and chemical engineers cohabitate and cross-train each other. And in doing that, they become more valuable products out in the marketplace. So that's what's unique about being at VCU, is what's right at this interface between chemistry and chemical engineering. And I'll talk a little bit more about that a little later. But so how did we get started? One of the last things I did when I was in industry, for those of you who don't know, I spent 32 years in the pharmaceutical and chemical industry and retired in late 2007 and got recruited out of retirement to come to VCU and to try and build a bridge between the chemistry and the chemical engineering department. One thing led to another, and much to my chagrin, next thing I knew I was department chair. So one of the last things I did when I was in industry was to develop a process for what is now one of the most widely prescribed HIV drugs. It's called nevirapine. And through a series of different discussions and connections, the Gates Foundation found out I was here. And so in 2014, they gave us our first grant to look at nevirapine and see if we could reinvent how it was made and produce it more cost effectively. The interesting thing about that is if we reduced the cost of that drug 10%, they gave us $5 million in a year and a half to do that. We actually reduced the cost of the drug 40% in 6 months. And I felt very embarrassed about that because I had developed the original process. I thought it was actually pretty good at the time. So, so they gave us a second drug to work on, and we did the same thing with that. And then they gave us a third drug, and when they gave us a third drug, they said, look, we're really interested in having you look at other drugs that are not HIV drugs, like malaria and tuberculosis drugs. And I said, well, you know, I can't do that. It's just one of me here. And they said, well, what if we gave you enough money to build an institute? And so on top of the $15 million that they'd already given us, they gave us an additional $25 million. It's a 5-year grant. It's renewable right now. So they've given us, between 2014 and the present, they've given us $40 million. And as I mentioned earlier, initial target was to reduce the cost of an HIV drug. Well, not only did we reduce the cost of that drug, but we actually reduced the carbon footprint dramatically. And people in the pharmaceutical industry still use this as kind of a benchmark. that drug wasn't generating as much waste as most pharma processes. It was generating about 80 kilograms of waste per kilogram of product, which is pretty low. We cut it to 4 with the new process. And with that, we won the Presidential Green Chemistry Award from the EPA in 2018. We also won the American Chemical Society Award for Sustainable Green Chemistry and the Peter J. Dunn Award, which are the 3 major awards that are given for green chemical processing. So we were very fortunate with that. And then we added the work on tuberculosis and malaria to be able to round out the work that we were doing at the Institute at the Gates Foundation's request. So then COVID hit in 2020. And for those of you who are doing research here and were not doing work related to COVID, unless you were working on a COVID-related project, you weren't allowed to work in your laboratory. So I called the Gates Foundation. I said, look, you're paying for 40 people standing around here. Can you find a COVID project for us to work on? And so they gave us this one. It was remdesivir. And it was interesting because I got a call from them. They said, take a look at this process and let us know what you think. And I said, well, after looking at it, I said, I think you're going to have a really hard time making this starting material because I've never seen this system, cyclic ring system before. And I've seen a lot of these types of compounds. And so they said, well, we'll get back to you. So 2 days later, they called me and they said, you were right, that starting material is a problem. Bill Gates met with Angela Merkel and the head of Gilead yesterday to look over the clinical results, and the president of Gilead confessed that they didn't know how to make the starting material. So we took a 6-week period, we put everybody on it, and in 6 weeks we knocked out how to make it from basically earth, fire, and water. So the problem is we probably should have taken a little longer because then I had to go back and ask them for another molecule to work on. So then they gave us molnupiravir. For those of you who don't know what molnupiravir is, it's the Merck drug that came out. And the real advantage to molnupiravir is that remdesivir had to be given by IV. And the concern was that it would still overwhelm the hospital system. So molnupiravir is an oral drug, and it was the first oral drug that was approved by the FDA. So they gave us that drug, and we looked at the cost and the process to make it. And we were really concerned about the supply chain issues with that. They were starting with adenine, and we wanted to start with cytosine as a key building block for making the material. And it was a fraction of the cost. And we developed an entirely new process that started with an entirely different building block. And we cut the cost of that drug from $1,700 a kilo to $160 a kilo. We did it in about 3 months, and we reduced it from 5 steps to 2 steps. And so then after that, they came back to us and they said, okay, we think you found a sweet spot here, so why don't you look at Paxlovid? So we started working on that back in, I think, November, doing some paper studies on it. And in December, I got a call from an old friend of mine, Stefan Caron, who's the vice president of Pfizer, his research group. He said, Frank, we think that this drug is going to be the biggest drug we've ever had to produce. We're looking at 2,000 metric tons of this drug to supply the market, and we don't know how to make the starting materials for that. So we'd already gotten a head start with the Gates Foundation, so we're working with them now on developing new low-cost methods to be able to make those 2 key starting materials from really simple, readily available commodity-based starting materials. So with that, for those of you who don't know what the medicines patent pool is, it started several years ago when HIV hit, back in the 1990s. The pharma companies recognized that they couldn't make any money selling HIV drugs to places like Africa and Asia. And so they took the intellectual property and assigned it to the UN. And what the UN did was they gave licenses to manufacturers in India and China to make these HIV drugs, with the restriction being that they could only sell those drugs, the material produced under those licenses, into Africa and Asia. So they couldn't sell them to Europe, US, Singapore, or Japan. Well, how does that fit into work we're doing with these COVID drugs? Well, Merck and Pfizer have put these 2 drugs into the medicines patent pool, and I guess it was about 2 or 3 weeks ago, we got a call from the Medicines Patent Pool, and what they said was that for the molnupiravir process, when they issue a license for that drug to a manufacturer, they're going to attach our process to it. So they know that they'll be using the low-cost process to manufacture the drug. And then from there, we started getting questions. They started referring people to us about how to work with them on trying to get the cost down for both Paxlovid and molnupiravir. So that's the direct COVID issue that we've been working on for the last 1.5 years or 2 years. But the other one is this issue about the supply chain. We talked about it earlier. And I have a good friend of mine, and this gets back to Jamie Stillman and I were talking about this before the symposium. And I was telling her that one of the talents that have been lost by this generation, and it makes me sound like an old man, is that students don't talk to one another, they text to each other. And that's eliminated a lot of dialogue that takes place these days that is really beneficial. And so I have a network of a lot of friends, and so I have this lady who wrote this book. It's called China RX. Her name is Rosemary Gibson. And that's the starting point for this other side of the story. Rosemary came to see me in 2018 to talk about the work that we were doing with regards to the supply chain issues. And unbeknownst to me, she'd been given testimony on the Hill about this whole supply chain vulnerability issue long before COVID hit. So the people in the federal government, when COVID hit, were aware of what we were doing, and so they called us and they said, what can we do to re-onshore pharmaceutical manufacturing back in the United States? And I said, well, it's not a simple problem because the Chinese are not only making the formulated product and the active ingredients, they're also making the starting materials, so you're gonna have to come up with a holistic solution. And I had an idea, and so I told them, I said, I've got some folks that have the capability to do this. And they said, okay, it's like a Thursday in February, mid-February, and they said, we're gonna bring our team down from the government. And they descended upon Richmond on that weekend, that Saturday, and they brought the leadership from HHS, Department of Defense, Office of Management and Budget, and other people that I didn't even know who they were. But they showed up, it was about 16 of them, showed up in black SUVs. And I thought they were gonna cart me off at first. But I called my friends that I knew that were working in this area, and one of them was a gentleman named Martin Ventris. And Martin is kind of a misfit like myself. And Martin had started this company called Civica RX. He was part of the leadership at Amgen and had retired a lot like me, and he got recruited out of retirement. So he came to see me, and he had started this company. It's a consortium of all the major hospitals in the United States. It's the Mayo Clinic, it's Kaiser Permanente. Actually, VCU is a member of it. And they had lost a significant portion of their operating room capacity because they couldn't get the drugs that they needed to support the procedures. And so they felt like if they consolidated their efforts, they'd have enough critical mass to make their own drugs. And so that's what Martin was doing. But he was doing it kind of virtually. He was importing the active ingredients from China and then formulating them over here with contract manufacturers, and he was worried about this vulnerability of the supply chain. So he asked me to be thinking about that. So when HHS came, I called Martin, I said, can you get here on Saturday? And he said, sure. So then the company that I used to work for, Boehringer Ingelheim Pharmaceuticals, had sold the facility that they have here in Virginia, in Petersburg, to a company in California, Ampac. And it turns out the CEO of Ampac, he was the graduate student for one of our faculty members at VCU in my department. And I'd known him for a while, so I called him and I said, you just bought this facility, how'd you like to fill it up with some new products? So he flew in the next day. So we formed this consortium through BARDA, and we received $362 million to do this, and we formed this partnership between Civica, Ampac, and this new company, Flow Corporation, that we started to try and generate a US-based pharmaceutical manufacturing facility. And of that, $362 million, 32.2 million of it was going to M4All to develop the new processes that are going to go into this facility. So then, I guess most recently, you all have heard about the Build Back Better program. Well, there is funding from Build Back Better that's already been approved. And we had received a grant from the state of Virginia to try and look at how we could build a regional hub of technology to be able to develop new capabilities to produce pharmaceuticals much more efficiently. And so we built up a business plan for that over the next 18 months, and my friend Jeff Gallagher led that effort. And we finished it in August of last year, and in September, the White House issued this request for proposals for Build Back Better for new ideas for hubs and clusters that could be put together in different areas, not just pharmaceuticals, but textiles and all kinds of different things. So there were 530 applicants for the round one funding, and they cut it to 60, and we were one of the 60. And what's going to happen is we're finishing up our proposal for the phase 2 review. We'll submit that mid next month, and we'll hear by May. And that's $70 million to build this national hub for advanced pharmaceutical manufacturing between Richmond and Petersburg. So in parallel, many of you probably know Congresswoman Spanberger. So Abigail's been a big advocate of what we're doing, and she's kind of a closet geek, I would say. She really has enjoyed talking to us about what we've been doing, and has been a real advocate for us. And so what she did was, about a year ago, she submitted a bill to create centers of excellence in academia for advanced pharmaceutical manufacturing. And so that's going through, it's been approved through the House, and it's going through the Senate right now. And that would give us another $20 million that would focus strictly on Medicines for All. Now, what does this mean to the region? I think the really important thing about this is that this would create a national hub for advanced pharmaceutical manufacturing, and there's nobody doing this. I mean, the reason why people have come to us is because we've identified some vacant space where there's an unmet need. So the other thing I'll say is we're taking that model that we have here for developing an onshoring activity for pharmaceutical manufacturing, and we're also looking at doing it in Africa. One of the things that I found is, in talking with folks, is the folks at the United Nations told me that between 50 and 70% of the HIV drugs consumed on the African continent are either counterfeit or adulterated. And when you underdose an HIV patient with an HIV drug, they build up resistance and they can't take it anymore. So basically, it's a death sentence. And so one of the things we've been doing is we're taking the processes that we've developed for HIV and COVID, and we're transferring over to a company that we've been working with now for about 2 years to be able to produce these drugs so that they can not only control the access to the drugs, but also control the product quality. And so there's another area that we're working on that I can't talk about yet, but it's probably bigger than anything that we've got here on the map right now that will support this whole national hub for advanced pharmaceutical manufacturing. So with that, the question is, why VCU? So I've divided this into 2 areas. One is institutional drivers, and the other is personal drivers. So from an institutional driver perspective, why is all this stuff happening with us? And I think a lot of it has to do with the fact that I'm a square peg in a round hole. That am I truly a good fit with academia? Probably not. But I think that the issue is that I think differently, and I also am pretty good at coming up with big ideas. And thinking, my wife's here tonight, and she will probably tell you, I don't think out of the side of the box, I can't see the box. And so what that does from a VCU perspective, it stresses our system. And I push the system pretty hard. And Dr. Kellerman's here tonight, and I know he does the same thing on his side, so Art, many thanks for that. And so pushing the envelope is what I've always done, and I think it's something that's going to make a difference here at VCU. Now, the other thing I talked about earlier was going where other people aren't. One of the things that I recognized early was that in academia, we aspire to be like the UVAs of the Virginia Techs. I don't want to do that. I want to be different from them. And I think the problem is that if you look at MIT as an example, if we try to go where MIT is, we're going to lose. And the trick is to find those spaces where other people aren't, where we can make a difference. And I think that's one of the reasons why we've been successful. The other thing is, I've got a short runway. I turned 71 this year, and so I'm as impatient as all get out. And so I tend to push the envelope faster than maybe most people would. And the reason why is, if they fired me, I could just go back into retirement. This is actually not a bad deal. So lastly, I think, and Fotis mentioned this earlier, and I think this is really important about our successes. It has to do with partnerships. So what's happened is all these different major universities have reached out to us because they know we're onto something. I've had a major grant with MIT for about 3 years, and they come to us for advice on how to do things the way we're doing them. Georgia Tech is one of our collaborators. And then we have these international partners at University of Graz and at Mainz University in Germany, as well as University of Washington and Rutgers. And so what you can see is it's not just about reaching out within campus to others. One of the things I'd say is one of my biggest assets, and one of the few assets that I have, is that I know what I know and I know what I don't know. And what I do is, instead of spending a lot of extra time figuring out how to know what I don't know, I find a partner who's already there. And then he educates me, I assign it to him, and he moves that forward. And that's been one of the great success stories of the work that we've been doing here. But lastly, and most importantly, the reason, I had one of my colleagues, Eric Edwards, who's the CEO of Flow, asked me the other day, we were at dinner, and he said, "What can you get off of your plate?" And I said, let me rephrase your question. I said, what is it that I'm not willing to give up? And it's the relationship to the students. I think the really important thing that I'm adding value to these students on is transferring knowledge from me to them. And the interesting part of that is that we're never going to be able to solve the grand challenges in science of the 21st century if we're making 20th century mistakes. And I've made those 20th century mistakes, and I can pass on to them what doesn't work so they can focus on new mistakes. So with that, I think that it gets down to this. We need to get comfortable with being uncomfortable. And I know that sounds like a bit of a misnomer, but I think that's, if we can create that culture where we're trying to continuously push the envelope to make this place better rather than being like somebody else, I think we're going to be very successful. And with that, I want to thank you for coming out tonight.
Thanks so much, Frank. Your sound? Yeah. Thanks so much. It's so good to hear you talk through all that. We received a bunch of questions, as you know, and what I tried to do was group some of those thematically and into sort of 3 or 4 groups and try and pose some of that to you. It seemed to me that, and then we'll open it up to further questions from the audience that we have here at the ICA. So first of all, we got a number of questions really about in a way, how the drugs can be industrialized, sort of moving to scale, the nature of the innovation that's entailed with that. Questions around speed, efficient paths through various kinds of infrastructure. Is there something that you want to share or say about what are keys to that step in the process, those steps in the process?
Yeah, this is, first of all, I think I touched on this earlier, Dominic. I'm glad you mentioned it because it starts with the chemistry. And if you can develop really good, robust chemistry, things get a lot simpler. The other thing I will say is that this is not new technology that we're working on. this continuous manufacturing approach. It's new to the pharmaceutical industry. It's been practiced for years in the chemical industry because they work on tight margins and they can't afford to do things inefficiently or they'll be operating at a loss. So that's kind of built into their culture, and I think that was one of the fortunate things. Having started my career and working in commodity chemicals, I have that mindset. You know, it's funny, I had a grad student of mine who was just doing his proposal defense, and he was with his committee and they were asking the question. They said, why did you use this support system rather than something else? And the guy didn't miss a beat. He said, because it's cheap, Dr. Gupton's cheap. And the other reason was it works. But I think that the really good news about this, Dominic, is I think that we have willing partners that will not only help us to develop the new chemistry and translate them into lower cost manufacturing platforms, but also we have partners at the FDA. You know, one of the things that I've been very fortunate is one of my other colleagues is a gentleman named Marshall Summer. And Marshall is head of the Rare Disease Division at Children's National Hospital. And Marshall is personal friends with Janet Woodcock. So Marshall says, she needs to know what you're doing. So he set up a meeting with her, and he said, just be prepared. He said, she'll be 10 minutes late, and she'll leave 15 minutes early. So when I got there, she was waiting for us. She had her whole team there. And instead of spending an hour with us, she spent 2 hours with us. It's that important because this whole drug shortage thing existed long before COVID. I don't know if you all knew this or not, but there's a saline shortage. Think about that.
There's a what shortage?
Saline.
Saline.
So how many people go into a hospital and get put on an IV drip? Mm-hmm. Why can't we make saline? If we can't make saline, why would we even thinking about making drugs? Mm-hmm. But these are the things that I think are fundamental problems that are just have been under the radar screen until COVID hit. So, you know, I tend to be a pretty half-full person. And so I look at this COVID epidemic as a way of saying, this is a unique opportunity for us to fix something that's really broken. Mm-hmm. And if we don't fix it now, people will forget it. There's a burning bridge right now, and we need to do something about it. And I think this issue about how can we do this quickly, we're doing this in record time. Usually it takes somewhere between 5 and 7 years to do this. We're going to probably get it done in about 18 months. Mm. We've already developed the processes for the first 2 drugs coming out. They're going to get scaled up. They're being scaled up right now. And while we're building the facility in Petersburg to make the drugs. And then we're going to transfer them over as quick as we can. And we're not going to be on the critical path. You know, BARDA had asked us to do 4 drugs in 4 years. We're doing 5 drugs in 2 years. So we're way ahead of schedule, and I'm just not going to stop. We're just going to keep working down the list. You know, one of the funny stories, I got a call from this gentleman, Peter Navarro, who was head of commerce for in the president's cabinet. And he said, you need to come up here and talk to me because we need to talk about these essential medicines. So we went up there, and he said, we really need you to get working on these right away. And I said, okay, do you have a list? And he looked around the room, and nobody had a list of what they needed to be working on. So I went back home. That was Friday night. I went back home. I spent Saturday, and Sunday I came back to him, and I said, here's a list that I think would be sufficient. And it turns out he shared it with the folks at the Department of Defense, the FDA, and also at HHS. And we were about 90% right. Mm-hmm. And I think what's happened is it's raised our level of credibility with those people that make a difference in this whole issue about how do we get from the starting point to products in the marketplace.
There's that, what you're saying there at the end, that kind of relates to something else that came through as a theme in some of the questions, which was to do with the motivations of the partners you find yourselves working with. And you know, one theme of your whole approach is this collaboration across very different sectors of society, in a way. Is there, how do you Yeah, I guess there were wider questions of culture, of politics, of economics. I can see you smiling at all this. Are there ways in which, is that a particular challenge? I mean, divergent sets of values or anything like that?
A couple of things that come to mind, Dominic. One is, somebody asked me, how did we get here doing this? And I said, everything had to happen exactly the way it did for me to be here doing what I'm doing today. And I think that it gets back to talking to people. I mean, it's pretty simple. Marianne Vermeer's in the audience. Marianne knows who I talk to on a regular basis. And all the pieces, this is probably the easiest thing I've ever done in my life. All the pieces of the puzzle have fallen together, and I think because there's this huge unmet need. And I think people have recognized it. And I think the idea, this gets back to this issue about the elevator speech. And I'll digress for a minute because I know Bill Lamp's in the audience. He's the head of our College of Engineering Foundation, and Bill's very passionate about what we're teaching their students. And one of the things I teach the students is the elevator speech and how to be able to tell somebody what you're doing where it can relate to them. So, and I tell them it's about the hook. So when you start with a discussion with somebody, what you want to do is have them ask the next question. So if you tell them everything up front, then they'll walk away. So more often than not, people will come to me and they'll say, well, what is it Medicine for All does? I said, very simply put, we're increasing access to global health care. And then they say, well, how do you do that? And it just goes on, and I think it makes it really easy to have that discussion and to put those pieces of the puzzle together because they know somebody who knows somebody else. And that's how it ends up. I can tell you, it's a too long, convoluted a story to tell you, but the Gates Foundation funding came from an airplane ride by my neighbor to Jakarta to see his leather boot company. Now, how is that related in any way to this? But these are how things happen. And so I think about that all the time.
So there are oftentimes personal connections can transcend the sort of institutional building blocks that people find themselves in.
Exactly. I agree. I agree with that wholeheartedly.
Another set of questions were about the work that can happen in the third world, in countries and parts of the world that are in conditions of poverty, and in particular, we talked about various agencies coming together. What are the particular considerations there in terms of pharmaceutical companies working with local government, state government, other kinds of players in those contexts?
Here's the thing I see. So one of the things that I think that, I'll just back up a second because it's a really important aspect of the question that you're asking. And that is, why is it people that distrust the pharmaceutical industry so much? It's because of the lack of transparency. One of the things that we're doing that I think is kind of a little bit of heresy is when we did the BARDA grant, it came as a result of a discussion I'd had with the folks in Africa. They said, why are you doing this? And I told them, and they said, well, what else value can we get out of this? I said, we'll open our books up to you. We'll show you exactly what the cost is, and then it'll be up to you to make sure that we have a sustainable margin so that we can keep the doors open. And if we all are aware of what the costs are, then we can work together to solve the problems. And I got that because I started this discussion in 2017. I was invited to give a talk in Johannesburg, South Africa, about the work that we were doing. And there was a gentleman in the audience who owned a pharmaceutical company that was making animal health drugs. And he said, can you stay another day? He said, I want you to come see our facility. And I went out to see it, and it was just like one of our plants when I was in industry. And I said, you guys can do this here. And so we started transferring processes to them and working with them together. And what that did was, I'd been having this discussion with the Gates Foundation for some time, and they didn't believe that Africa could do this. And so after I transferred the first process, they kind of said, maybe this is possible. And with COVID, maybe it's a necessity. And so that's kind of the impetus for that. But they took me out to dinner with a member of the cabinet of the government in South Africa. And I asked him point blank the question. I said, why are you funding these guys? And they said, simply put, we're the single largest procurer of HIV drugs in the world. And if we know what their costs are, then we can be much better, more effective at purchasing strategies for these drugs. And I think it's the same thing here in the US, that we can translate that over here and be a much better and wiser consumer of drugs, whether it's the government or a US consumer. But these are the things that, I consider them common sense, Dominic. And I have a great quote from one of my students. I say this all the time in the laboratory, and he turned to me one day, he says, Dr. Gupton, I'm sick of that comment. He said, common sense is not a blessing, it's a curse, because you have to deal with everyone that doesn't have it. And I thought that was a tremendous quote. He's going to do great things. He's at Pfizer now. So these are the kind of things I see, Dominic, about how we can think differently and being transparent. I think one of the challenges that we have is this whole race to the bottom and the cost of healthcare. This is a huge problem that has all kinds of unintended consequences. I mentioned this issue about saline. A lot of people said that the saline shortage was a result of a hurricane that hit the bag company in Puerto Rico that was making the bags for the saline. It happened long before that. And the problem was that the major manufacturers of the drug, of saline, the margins were so tight they didn't hold any inventory because there was a cost associated with it. And then when you got a spike in need, they were unable to supply the market. So these are things that I think that we tend to be short-sighted or tactical rather than strategic in our healthcare, and that's the last place we should be.
Mm-hmm. So the last group of questions, and then I'll open it up. There were a variety of things. I'm going to bring them together in a certain way. There was questions about how the resources of the university can support approaches to research such as you pursue. There were questions about a culture of communication that can take on science skepticism. And also questions about how, as we're doing tonight, we can share out the work that's happening. But for me, that all points to, or it comes back to your third question, which is why VCU? So what's the opportunity of a kind of a legacy public higher education institution like this for this kind of innovative research? Because in a way, your own answers to the questions was you're stressing the system, you're a square peg in the round hole. What is it, what is it that really this kind of institution, public research university, can really do in an area where others, including in industry, are also doing research? What's our singular contribution?
Well, I would start by saying I'm kind of bulletproof, and I'm not worried about being fired, so I'm not worried about pushing the system. And here's what I'll say is the leadership got this very quickly. President Rao and his direct reports, all of them got it and got behind it right away. And my dean at the College of Engineering was the same way. The problem was that we overloaded the system so quickly in the College of Engineering that it was very apparent that we had exceeded the capacity very quickly for things like hiring people, project funding. So to give you a perspective on this, Dominic, because I think this is really important for people to understand about where we are. People don't think about VCU the way they should. The College of Engineering, when we first started doing this, one of the ways they measure, they use metrics to measure the value of a program for specifically, like say, chemical engineering, is they look at research expenditures because that's a source of income for the university. The university typically gets about 50% of the funding, but they only get it as the researcher spends it. So that's why research expenditures are kind of an important metric. So research expenditures for the College of Engineering when we started this were $5 million for the whole college. It's now, and Barbara had just come on board shortly after that, our dean, and it's now 26 million, okay? And that was in 6 years. But of that 26 million, 13.8 of it's from my department. So this stinky little department that we got at 10 faculty members, not, and I know Natasha's here, that isn't meant to be irreverent, Natasha, but our little department represents well over half of the research expenditures for the entire college. So then getting back to this issue, Dominic, about measuring us against UVA and Virginia Tech, us wanting to be like UVA and Virginia Tech. If you look at UVA and Virginia Tech's, UVA's chemical engineering department, I think is 2.8 million. Virginia Tech's is 3.4. We're 13.3. Mm-hmm. I don't want to be like Virginia Tech. I don't want to be like UVA. I want to be like us. And I think the really interesting thing is, look at it on a national level. We're in the top 5 chemical engineering programs in the United States in research expenditures. We're ahead of MIT, we're ahead of Georgia Tech, we're ahead of MIT, we're ahead of Caltech. We're just behind Cal Berkeley. And if you take the number and you divide it by the number of faculty to normalize it, we only have 10 faculty. So it's $1.3 million per faculty member. And that puts us number 2 behind Cal Berkeley. So, and we're closing in on them. With this next thing, we'll pass them. So you think about that. How many people in the audience knew that? If there's one thing we do poorly, Dominic, I think it's telling our own story. And I think that that's something that we should be doing a whole lot better. And I think that we will in the future because I think we have a story to tell now. And I think that it's not just me, it's everyone that's working around this space because I've got some great faculty in my department and they're all contributing to our research program. So, you know, I think those are the kind of things that I think about when it comes to how do we change the paradigm here? And part of it's being proud of what we do. And I think that too often we say, oh God, we're not as good as UVA, we're not as good as Virginia Tech, and we don't have the endowments that they have. Well, that's going to change. Mm-hmm. And I think it's going to change with all of us. It's changing the way we think about things.
Mm-hmm. Well, let me open it up to those, to invite questions from those we have here in the audience. For the remainder of our time. Yes, I think we have some microphones moving around. Yeah, it's Art Kellerman.
Frank, thank you very much. I'm with you.
Art, could you, if you take the mic, then it'll be heard online as well.
Frank, thank you very much. And I'm absolutely with you on the fact that we can run rings around these folks if we just be us. And not try to be other folks. And you're a fabulous role model for that. And by the way, I noticed something else that you did. As successful as you are, you kept calling people out in the audience because it's about the team. It's not about any one of us, and that's fabulous. I got one little wonky question. The FDA, as you know, given your background, is incredibly difficult to get things through because they're always wanting phase 1 and then phase 2 trial. It sounds to me like if you can come up with a way to manufacture the same generic drug, you don't have to run through all those hoops, and yet you will make a treatment more available to more people at an affordable price than all the Me Too manufacturers and the folks that are trying to develop the next $250,000 a year drug put together. But am I right about that?
That's exactly right, Art. I think the one that kind of got me was. And you, I know you all are working with the children's hospitals, and the stories that I hear from the drug shortages at the children's hospitals are just unbelievable. I mean, they work on tighter margins than anybody because their volumes are so low. And I think that these are opportunities to be able to think differently. I mean, you know, so the cost to make a drug. To give you kind of for instance, this gets back to my friend Marshall Summer. Marshall had a friend of his named Tom O'Malley, And Tom's daughter, Tom is probably conservatively one of the wealthiest guys in the United States. He owned half the oil refineries in the world and sold them to Phillips Petroleum. But he had a daughter who had a urea cycle disorder. And Marshall had been her physician ever since she was born. And so Tom invested in a researcher at Hopkins to develop a process, a drug to be able to treat it. And so the guy developed it. And this gets back to the cynicism that we get to with regards to what we're doing, Dominic. He sold it to a pharma company. And then the pharma company developed it. And these are two things that are they're preservatives and sodas. So they're cheap, I mean, really cheap. And one vial of this stuff was marked up to $15,000. And the shelf life of it was so short that the hospitals couldn't keep it in their inventory. And so that when a child got urea cycle disorder, if they didn't get treated right away, they'd start to get brain damage. These are the kind of things where there's an unmet need. And I think the FDA recognizes this, Art. And when we start looking at these problems that there's currently not a solution to, the ICA, the FDA can give kind of special dispensation to get these things accelerated. And once you start doing enough of these, it shows that we can do these things faster than we've done them in the past. And I think they want to.
Hello.
If you hold on for the microphone, then folks can hear online. Melody? Oh, you have a microphone?
Oh, yeah.
Oh, I'm sorry.
When you talk to big publicly traded pharma companies, how do you get them to find a balance between the bottom line and providing quality medical access for everyone?
I don't think the big pharma companies are the problem. I think the big pharma companies have too much at risk because what they're having to do, part of the things people don't understand, and I think having been in the pharmaceutical industry for a number of years, I'd say they probably do a much worse job of communication than VCU does. And I say that, you know, in the worst sense of the word because they spend inordinate amounts of money in developing these drugs at really high risk. So basically, I think it was like 1 in 10,000 compounds that they work on ever sees the light of clinical trials, much less the marketplace. Right now, it's costing $2 billion to develop one drug. And part of it is the clinical trials and the time it takes to do them and the cost associated with that. And when you get failure at that stage, then you're spending a lot of money on a drug that's never going to make it to the market if you get a failure. So the challenge is, how do we incentivize drug companies to do things in a way that's going to be an acceptable risk? Because I think that part of the FDA strategy is basically zero risk. And there's a huge cost to zero risk. But if there's a manageable risk, I'll give you another example. We had when I was in the industry, we developed a hepatitis C drug. And you could give this drug to a patient who had a clinical profile of less than 30 days to live if they didn't get a liver transplant. And you could give them 2 doses of this drug and they'd be out of the hospital in 2 days. It was an amazing drug. But when they were doing the tox studies, they found some cardiotoxicity issues in the drug. And in a small percentage of the population they were looking at, the animal studies, and they decided to pull the drug because they couldn't take the risk. And I think that this issue about risk mitigation becomes a really important element. And quite honestly, Dominic, this is what I tell my chemical engineering students every day. And we talk about it in class, and they say, you know, what is it that chemical engineers do? They mitigate risk. And I think that one of the things that's done is it's permeated our laboratory. But I think we need to do more of that because we've kind of become such a litigious society that nobody wants to take any risks anymore. And so I'm an old guy, I can take risks, and I'm not really worried too much about the consequences. So I think that's one of the things that's going to change the way we do things. Maybe getting some more old guys like myself in academia would be a good thing.
We'll all get old eventually, so maybe one more question if there is one. Oh, we have 2 more. Let's take 2 more then. Yes, thank you.
Dr. Gupton, thank you.
If you could take a microphone, that'd be great, because of the folks online.
Dr. Gupton, thank you for all the great work and leadership. Dr. Gupton, in my discussion with a wide variety of specialists, each of them can arrive at a list of 5 to 10, sometimes more, medications. You multiply that across all the different specialties, and you have a very daunting list. How then does your program, do you narrow that down?
I think that the shorter answer is not very well. I think that, but we're getting better at it. And I think that the criteria is, and getting insights from these different agencies. So we've got a list of 100 compounds now, or drugs that we're looking at. And the question is, how do we prioritize them? And so what we've been doing is leaning on the work that the other agencies have been doing, and also looking at the hospital systems. By networking with Civica, who's already plugged into the hospitals, they know where the gaps are, and we can start prioritizing them that way. So the first 3 drugs that were 5 drugs, I'm not allowed to talk about which drugs we're looking at because they don't want China to start making the drugs and lowering the price on it. And I think that, this gets back to another point, Dominic, because this is a question I usually get asked, so I'll just answer it because it's related to this. Is when I got a call from Senator McConnell when we got this money, and he said, Dr. Gupton, I'm opposed to this funding for you. And I said, why is that? And he said, well, I'm a free market guy. I said, so am I. And he said, well, why do you consider this funding supporting free market? And I said, Senator McConnell, you don't understand. I said, we're not competing against Chinese pharmaceutical companies. We're competing against the Chinese government because the Chinese government is underwriting all these investments to allow them to operate at variable cost. And so what you're doing is, by making this investment in us, you're creating a level playing field for these drugs that currently aren't being made because nobody wants to make them and there's no money to be made at it. So these are things that I think that is, from the standpoint of what we're doing, we're prioritizing them based on the feedback that we're getting from the hospitals, the FDA, Department of Defense, and HHS. And I think that that's probably as good as we're going to get right now, but we're going to get better at it as we go down the road.
And then one last question here in the third row. Thanks.
Hey, it was kind of on a similar note. I'm a 4th-year student in the School of Medicine, and I'm applying into OBGYN with an interest in gynecologic oncology. And I was wondering, you had mentioned the HIV drugs and how if you're at subtherapeutic doses, you will build resistance. And a similar thing can happen with cancer drugs. And so I was wondering if those are somewhere on your list, or if maybe more timely things like, things that can work against COVID or things like that take higher priority, which was a little bit mentioned earlier.
So did I hear you say correctly you were working in oncology?
I'm interested in gynecologic oncology.
Okay,
Yeah.
this is really interesting because I'll back up a second because this was one of the things that I'm most proud of is that drug I was telling you about, nevirapine. It was the 2nd drug approved by the FDA for treating HIV. It was the fastest drug ever approved by the FDA, and it was approved in 6 weeks. And the drug, one of the reasons why the drug, I'm proud of it, is at the time, I don't know what the situation is now, but at the time, approximately 30% of the women of childbearing age had HIV in Africa. You could give the expectant mother the drug before she went into labor, give 2 doses of it to the infant wouldn't have HIV. It was an amazing drug. But the cancer drugs are a little different. And here's the thing I'll say about them, is I worked on a drug called Velcade when I was in industry, and it was a really nasty drug. It was probably one of the most potent drugs I've ever seen. 25 kilos of this stuff treated the entire global requirement for lung cancer. And it was so toxic that we had to build a separate system to work on it. So working with cancer drugs represents a significant challenge, and you have to kind of pick your spots on which ones make sense to make in the lab safely and which ones don't. But there are ones that we can work on that fall into that the category that we can work on safely, and we will work on them.
Thank you.
You're welcome.
Frank, thanks so much for being here tonight. I know that you're waiting, you alluded to this, waiting on some big decisions that could be really transformative for the research. So best wishes for that. And I'm glad we had the chance here tonight in the context of this series to share a little bit about what this research is and the impact that it's
So
having.
for the takeaway message for all of you who are either streaming online or in present today, if somebody asks you what Medicines for All does, just say they increase access to healthcare. And that's a message that from a communication standpoint that we hope that you guys can convey to us. One of the things I always say to my students is there is no free lunch. So now you guys are advocates. You need to go out and spread the word. Thank you.
Thank you. Frank Gupton.
Thank you so much.
That's wonderful.